I'll talk to you.
That's right.
Okay. Should I wait for his cue?
Okay, go for it.
Go.
Yeah.
Hello. Can you hear me in the back there? All right. All right. I'd like to welcome you to the, you guys can hear me, right? All right. Thank God I'm from New York, so I can be very loud. Welcome to the Autodesk Gallery and to Design Night. I'm Bill O'Connor. I work here in the San Francisco offices of Autodesk, and we're very excited to have you guys here. Who's been to the gallery before? Show of applause. And wooing is good, too. Woo is always good if you need to woo. So thanks for coming back again. We're also very excited to have tonight with us Leo Villareal. I pronounced that in the authentic way, I think, right? The artist whose amazing Bay Lights installation was unveiled just this week, just a short distance away over there on the Bay Bridge. Leo is known around the world for his light sculptures and site-specific architectural works. His art is part of the permanent collections at the Museum of Modern Art in New York and the Naoshima Contemporary Art Museum in Kagawa, Japan. He's got a long list of major site-specific works, including Multiverse. It's in the National Gallery of Arts Concourse in Washington, D.C., and Hive, which you can see in the Bleecker Lafayette Street subway station in Manhattan. So running the gamut, to say the least. Please give a warm welcome to Leo Villareal.
Thank you. Thank you. Thanks for coming tonight. It's really thrilling to be here in San Francisco and to finally be able to unveil the Bay Lights. Just want to talk a little bit about my work and kind of how I got to where I got. I started out way back when studying sculpture. That's when I decided I wanted to be an artist. I was at Yale and I was doing installation sculpture and really into creating environments with found objects and video and light and sound. After I finished Yale, I found some other work that was very inspiring to me. I was in Italy, and I came to know the work of James Turrell, which is this sky space, and the work of Dan Flavin, who uses fluorescent tubes in his work. But what I realized was that art could be much more minimal in using space. These are some images from Marfa, Texas, where my mom's family is actually from. Donald Judd, the minimal artist, he went to Marfa in the 70s and bought a lot of the town and turned it into his own private studio and museum. And he dedicated many of the rooms to different artists like Dan Flavin. But there's a real purity to the experience out in Marfa because it's space, it's permanently installed. Here's some of Judd's boxes, aluminum boxes, and some of the pieces out in the landscape. This is James Turrell, who is another incredible artist who is building Road and Crater. This is Road and Crater. So James bought a huge amount of land in Arizona near Flagstaff, and he's taking this this crater and shaping it. And he's spent tremendous amounts of money creating this piece with various tunnels, with alignments, with different apertures. As you see a light at the end of the tunnel, and then when you arrive, it's this elliptical cut in the ceiling that's going through this keyhole, and at certain times of the year there's alignments and the sun shoots down the tunnel, and we're really dealing with light and space. Here's when you get up to the tunnel. You lay back on these chairs, and he's doing this effect where he's trying to create this vaulting effect and bringing the sky down, which is very exciting. He's an amazing and inspirational artist. After my experiences in Italy, I ended up deciding to go to grad school at NYU in the Interactive Telecommunications program, which has been around since the 70s, a very pioneering program. And I started there in 1992. There was no web at that point, if one can imagine. My work then was really, this is some work I did in taking television signals and dynamically remixing them into, dealing with abstraction with all these found materials. The other work I was doing at NYU, one of the reasons I went to NYU is because I wanted to get access to the Silicon Graphics machines that they had, and at that point, all this stuff was very expensive and hard to access, and I was fascinated by the idea of virtual reality, and the only way to really get your hands on this stuff was to be in an academic environment. So I ended up working at the medical center where they had the biggest and most powerful SGI. I was doing laparoscopic surgery simulators, and we were using haptic devices with sensors, and this ended up being a very good application for laparoscopic surgery because it's non-invasive, surgeons are inside the body, but they're looking up at a screen and they're using an extreme fisheye lens, and learning how to navigate within that environment was like very important, so it was kind of an ideal application. After I was finished NYU in '94, I met an artist named Michael Neymark. Michael's an amazing guy who spent a lot of time, he's an MIT guy, and his big obsession is capturing places, capturing and representing space. So Michael was working up in Banff, Canada, and he created this camera rig with two 16mm film cameras and an encoder on the wheel, and he spent all this time taking a series of stereoscopic pairs. And I came out to be the artist on his team with Paul Dubevic, who's another amazing guy. But we worked at Interval, and we took this series of stereoscopic stills, and our goal was to dimensionalize these. So we were extracting 3D information, creating depth maps, and putting pixels in space. So behind the trees is data where there's no data because the camera couldn't see that. But starting to shift perspective, you can see the camera and all the pixels kind of shooting out in space. We were doing this back in '94, which is pretty exciting, kind of early application. So really enjoyed being out here and being able to come out to Silicon Valley and live in San Francisco. The other amazing formative experience I had was going out to Burning Man. I started going out in '94 to the playa, and I've been out there every year since. I was amazed by the purity of the landscape and just the how much it reminded me of these kind of OpenGL demos that I'd been playing with back at Interval. So I saw this connection between these virtual spaces and what was happening on the playa, but here we were out in a physical space with a group of people who were building a city. This is what Burning Man looks like today, more like about 50,000 people, much more elaborate city. But one of my major issues at Burning Man was navigation. And when I went in '94, the only thing that was there was the Burning Man sculpture in the center of the city, but it was incredibly disorienting. My first experience at Burning Man was getting profoundly lost. And it was interesting as a 20-something-year-old to be, have this childlike sense of being lost and being in a landscape where you had to relearn to navigate. But people kindly helped me find my tent, and 3 years later, by '97, I decided I was going to do something about it. So at NYU in the physical computing lab, I created this sculpture here with 16 strobe lights and a microcontroller. And here it is out on the playa, mounted on my mobile home. It's sort of a wayfinding device. This is something I had to build in New York and figure out how to put it in a suitcase and get it across the country, and then reassemble it out in the desert. But it turned out that this was an incredibly exciting moment for me. This was my first light sculpture, and I thought of it as a utilitarian thing. I didn't really think of it as a piece of art. But what blew me away was the ability to make a piece with 16 lights and working at the lowest level of 0 is off and 1 is on, but making a piece that had this ability to communicate, and it had this sense of personality and being alive, and how I could do that with just 16 pixels was very exciting. So I'd been on this other path of needing faster computers and more sensors, and then we could do this virtual reality stuff. But what I realized was that I could do a lot with a small amount of information, and connecting software and light was the major moment for me. So this is in 2003. I did my first large-scale piece using a piece of architecture. This is out at PS1 in Long Island City, and this is mounted on, they were doing a construction project, so this piece is mounted on the side of the building, and it's right near the LIE. There's a lot of billboards and advertisements, and I was interested in kind of participating in this media landscape, but creating a piece that dealt with abstraction. But what was interesting is how much people responded to it. I mean, there's a gas station right there in front of the piece, and the gas station attendant was very aware of the sequencing and when it would change and would ask about it, and taxi drivers, and suddenly I was engaging with a really wide public, and I realized how much of a focal point these pieces could become. Here's a close-up of this installation. This was done in conjunction with a show called Signatures of the Invisible, which was done by CERN, and they collaborated with some artists. It was a very exciting show. This is some kind of behind the scenes, how it happened, pictures from my studio. We custom made every part of this piece, from the circuit boards to the software, and we wired it all up and had very long soldering parties. So here we are putting it all together, wiring it up, because this stuff didn't really exist, and I had to make it. But fortunately, I've had this amazing community of engineers and some of my former students from NYU were helping me. This is the control center in Brain, which is look at it now. It's a little bit appalling. Not what the inside of the bay lights looks like at all. This is a more recent piece. This is Multiverse, which is using 41,000 white LED lights at the National Gallery in Washington. And this is a tunnel that links the east and west buildings. So for me, it's really been one piece leading to the next. This was a chance to activate the space that, even according to DePay's office, was somewhat unresolved. It was sort of dark, but it was optically very potent with these mirrored strips. So I knew that something really exciting could happen, and we spent a lot of time making simulations of this, using many Autodesk tools, very useful in showing people what pieces could look like in advance. And then we did a mock-up, and finally we were able to install the lights. But again, it was a little bit of a magic trick to install these lights in this gap between these slats. So we spent all summer making clips that no one will ever see or know about in order to hold the lights in place. But the really important part of this, my work, is the software and the tools. I'm making my own custom software. I like simple tools, things that are, I was particularly interested in John Conway's Game of Life, which is sort of the screensaver cliche, but the beauty of his rules and how such simple rules can generate these very complex patterns that you would swear were alive and from nature really got my attention. So my goal has been to develop my own software with my own rules and really working towards these, creating emergent behavior. So you create the parameters and then let it go, but you don't know in advance what's going to happen. And you wait for that moment. And when something compelling happens, that's what I capture and becomes part of the artwork. But my work is all abstract. I'm not using any images, no text. It's all about rules and underlying structures. There is some, I think we're all hard-coded to pattern recognize, and that's one thing I'm playing with, is you want to look at these things, and light is a very seductive material. So you spend time and you're getting some amount of information, but it's very slippery, and that's the area that I love, because it's highly subjective, and people can make up their own minds about what it is. The pieces are all randomized as well. There's no beginning, middle, or end. So that's also refreshing for a viewer, because you don't feel an anxiety about, oh, I missed something. And then it's also not something that you're supposed to get, because it's highly subjective. So it's really creating a space for a viewer to just really enjoy the work and be with it and to sort of relax. But this has been a very exciting installation, and this was supposed to be up for a year, and the National Gallery decided to keep it permanently. And it's exciting to be there, because there's so many, there's such incredible art there, and in dialogue with art history, and it's something very new for them. Using light and technology is not what they normally do. This is a more recent piece in another IMP building up at Cornell. This is the Johnson Museum in Ithaca, and this is a piece called Cosmos. So this is a grid of white lights, much denser. This is about half the lights that we have here on the Bay Bridge, but packed much more tightly. And this is a really incredible and radical building. It's up on a hill in Ithaca, and I spent a lot of time thinking about the landscape there, the gorges, the waterfalls, and all the kind of natural phenomena, and kind of channeling that into my inspiration for creating the sequencing. This is a really, I'm very happy that this is in an academic environment because it mixes all these things like art, light, software in a really unique way, and I think it's it's exciting to blend these things, and I think it's a unique fusion. This is another piece I opened this summer. This is a piece called Hive, which is in the Bleecker Street subway station in Manhattan. And these are LED tubes, which are ceiling mounted. And this is the MTA's first digital artwork. So for them, it's a really big deal to have a piece of digital art. And it was exciting to think about the trains and the network and the movement and the city and kind of reflect on that in the piece. So the sequencing, there's movement within it, there's overall pattern and orchestration, but then you start to see individual elements within that starting to move. So it's a hexagonal pattern, and it's, I ended up having to program this last July and August in New York. So if you can imagine the heat and being down in the subway and a pretty extreme environment, but a lot of my pieces are site-specific and require being there with them and programming them on the spot. Here's another piece I recently showed in New York called Buckyball, which this is a 20-foot sphere and then a 10-foot within it, and it was presented at Madison Square Park. So I was interested in taking this building block found in nanotechnology and making it a monument to this structure and then presenting it in this, in Madison Square Park. And it was surrounded by these zero-gravity benches so people could recline beneath it. Here's some video of it moving. So these are 4-foot tubes and 2-foot tubes, and I can control them every 1.2 inches as an individual pixel, and I can make any of those, any of 16 million colors. So there's a whole range to it. But this type of piece is also very different from these other grids. Each piece has its own quality, and it's something, again, that I have to kind of spend time with and decipher and figure out what it can do. Here's a piece that's on display in London right now at the Hayward Gallery. There's a show called Light Show, and if anyone's going to be in London between now and April, I highly recommend that you see the exhibition because it's a wonderful show. This is a piece called Cylinder, and this is using tiny LEDs about the size of a grain of rice, and they're built into these stainless steel channels, and then they hang from this upper structure and they hover just over the ground. But what's exciting for me is starting to get out into space. A lot of my earlier pieces were mounted on walls, but this is getting 3D and volumetric. So here you can see the interaction with the floor and the shadows. So there's a lot of light, but then it's also reflected. You have this mirror, which is reflecting. And the patterns, towards the top, it's all mirrored as well. So you get this kind of connection to the infinite. And the tools that we have I am working in 3D, and I'm able to visualize things and move light in and out. So we've been having to evolve our tools to include, this other dimension, but I have that ability. Here's looking up at the top of the piece. Thanks. So that brings us to the initial, to the Bay Lights. This is the original rendering that I made after Ben Davis, who's here, asked me to consider the bridge as a canvas and what could we do to celebrate the 75th anniversary of the bridge. So I spent some time working in 3D and figuring out how to create this visualization. But it's incredibly how powerful visualization can be. And you can talk about putting lights on the bridge all day long, but that means so many things to so many different people. But being able to show them was incredibly powerful. And we started showing this to people at Caltrans and people who run the bridge and finding allies. And people were incredibly excited about the possibilities. So, this project has been, there have been incredible challenges, but we found allies, and, here we are. I'll show you a little bit about what we've done. These are the LED nodes that we're using. It's a product by Philips, and this is rated IP66, which means it can be in wet and damp locations. There are 50 lights on a strand, and then they're hooked to these power supplies that provide power and also data. So each power supply has its own IP address. Here's some of the kind of technical diagrams that we've done. This is mapping out where the power supplies are going to go, because we have certain lengths of leader cables that we had to take into account. But we ended up installing a 1.8-mile long fiber optic cable along the bridge to distribute all the data, of huge racks of switches, computers. There's all this IT back end that no one will ever really know about. But that's really what it takes to do a piece like this. Here's a model that we used Autodesk tools to generate. Using photographs, we ended up printing this image of this model of a cable. One of our challenges was how to physically attach the nodes to the cables. You can see out over here in the museum a display, and you can see an actual piece of the cable and the clips that we designed. And Timothy Childs, who's here, he's on the board of Illuminate the Arts. He was very helpful in getting this clip created. Yes, thank you, Timothy. But this little clip is, we started printing stuff with MakerBots and trying to come up with the design, and you can see many of the iterations. This is how everything's attached, and I was surprised that our engineers came back and said, yes, we're going to attach it with zip ties, which I love that. But, zip ties are great, and they're UV resistant. Here's, I did a couple of cable walks up on the bridge. It's one thing to make these simulations in 3D, but it's a whole other thing to actually go up there and see, to get a sense of the scale of this structure. So it's 525 feet at its highest point down to the water. On the other side, it's 250 feet to traffic. But it's spectacularly beautiful. And when I went up on my cable walk, it was a cloudy day, and suddenly the clouds started to part, and the beams are coming down and activating the water, and it was just this really beautiful moment. So I was thinking to myself, if I could channel 1% of what I'm seeing out here into the piece, everything's going to be fine. So my inspiration for the Bay Lights comes from all the kinetic activity around the bridge, whether it's traffic or the systems found around it, water, the interaction of light in the atmosphere. But I look at these things, and I'm trying, as many of you are, I'm sure, trying to figure out how these things work, and how do you boil this down to an equation, or what are the rules that govern these things? So that's what I'm working with in my software, and trying to generate, use those rules in a way, as an artist, to create the sequencing. So here's some of our incredible contractors in a harness and this contraption. So all the work had to be done from 11 p.m. to 5 a.m. with lane closures. There's no pedestrian access, as you all know, on the Bay Bridge. So, the onslaught of hundreds of thousands of cars and, a couple of traffic cones protecting these guys. Here's installing some of our electrical panels. They're the cones. That's all they got between them and like the cars. So it's like this is not easy. So some of the work that I've had to do to make this piece a reality is to, obviously I couldn't set this piece up anywhere else and test it, certainly not in my studio in New York or anywhere else. But I created this scale model, which you all can see here in the gallery. I'm very happy to have it here tonight for you all to see. This is a black PCB with white LEDs on it, and it's to 1/3 scale. So in here, 1 inch equals 30 feet between the suspender cables. Here I am in my fabricator shop, and we're testing this thing. But it's been very useful to have this tool in order to be able to visualize some of the sequences. And what you're seeing here in the gallery are some of the sequences made for the bridge, but they're being presented on this piece, which is an artwork in itself. And so I make large-scale pieces, but I also make individual works that are light sculptures that can be shown in galleries and museums. One of the exciting things about the piece is that 4 of them could be put together to actually create a model of the bridge. It would be 24 feet long. Here's the piece assembled. But it was actually very useful to have this as a way of visualizing in advance what some of the sequences could look like. And now it's a nice piece to be able to take the sequences and actually display that same content. So here's, this has been my reality since about the middle of January. Sitting out on various piers and seeing the bridge from many locations, using my software to try things out, because I don't know in advance what this piece is going to be, and it really is, it's like a puzzle, and there's so many different angles to view the bridge from, and certain things work at certain scales. I can do very fine single pixel animations, but those are lost from, in Sausalito, there's no way you're going to see that. So that's required bigger gestures. So it's been a real tricky and complex, but really exciting to be able to see what's possible with the bridge. I've been kind of blown away by the amount of feedback we've gotten, just in social media and people presenting their work. This is a video that someone during my testing just created that I was pretty blown away to see this edited and put up on the web. And this was just on our early test in January. So thank you to Adrian Graham. And it's nice to be able to see the impact that this piece has had, and the way that it's really, for me, about creating communal experience. And people can't help but want to talk about the piece. You're down there on the Embarcadero, and suddenly you just have to share that moment with someone. So we're literally creating these spontaneous interactions in community, and being able to see people's experiences and all the and their feedback in the media has been really amazing. So yeah, I think that's pretty much it. I'd be happy to take some questions.
He's ready. Questions? Everyone?
Oh, sorry. Whoa, all the way in the back.
My sons who are 8 and 12 are very curious to know who fixes those lights when they break. Are you breeding monkeys that can climb the Bay Bridge?
Well, we have some incredible contractors. Parsons, Spreakerhoff did our technical design, Blaco, Transden. We have a whole incredible team. Zune Engineering, Saeed Shermadze is an incredible person who enabled this to happen. And we've been debugging since January and worked out a bunch of the kinks. I mean, we're still, figuring it out, and this is a very large piece. But I have a lot of confidence in Philips engineers, and we're working through it. I mean, supposedly the LEDs have a very 150 to 100,000 hour lifespan, which is that's 11 and a half years burning them at full power. This is a very harsh condition, but we'll see how it goes. We definitely have a budget for maintenance, but in my experience, once these things work, they work. So we'll see.
We'll take two more.
I'm interested in the rules. Can you tell us about the future of the rules you use and what insights about the universe the rules have given to you?
Well, for me, it's about really just kind of getting lost in it. I like, I have all kinds of knobs and sliders and parameters. And for me, I'm not a physicist or a mathematician by any means, but if I can make a tool where I can engage some of those laws in a way that I can play with as artistic material, that's what's exciting for me. So I'm waiting for those moments to happen. I don't necessarily know in advance. And I like, like I said, pretty simple tools, almost like dumb tools, where each pixel has a rule. You get to a boundary and you bounce. I mean, like Pong level. But when you multiply that by thousands of times, this exciting thing happens that you couldn't have anticipated. And then you start puppeteering it with other parameters like, viscosity and friction and all these things. Somehow, these things start to happen. And if you were just looking at it as pixels on the screen, you really might not even see anything exciting. But when you're looking at it on the bridge, it looks a whole different way. Authoring for this piece is very challenging. We have an LED spaced every foot vertically, and then the suspender cables are 30 feet apart. So I'm missing the 29 pixels in between each span. So it's, I think the aspect ratio, if you were going to create something, was something like 250 pixels tall by 8,000 wide. So it's a really kind of a difficult thing to wrap your head around. But for me, it's more about just getting in there and playing with it and tweaking it until you see something good. So I'm gathering these moments, and then there's another process of layering these things together into these much richer compositions. So I'm adding light, subtracting light, and in the end, there's a set of sequences which are displayed in a random order and for a random amount of time. So it's like a shuffle scheme, but instead of just this song and this next song, it's like this instrument within this 10 seconds of this song and pulling all these things together and dynamically recombining itself on the fly. So that's kind of the way that I've found to create these pieces, which are, they're pretty livable.
To touch on that subject that I was interested in, which is setting it, I don't mean to Disneyfy you, but at some point, could you set music to this or do the K-Fog Kaboom special and have the lights react appropriately? There was nothing kinetic in the previous art. It was all generated internally from your computer programs. But could you imagine a scenario in the next 2 years where that might be true?
I mean, I'm very inspired. I love music and sound, and I made some early sound pieces, but this is made just purely as its own kind of sequence. I've been in some shows, like a show called Visual Music that the Hirshhorn Museum put together that talked about the history of abstraction. And I think I was in that show because my compositional tools and methods are similar to what a musician might use. So in a way, it has a synesthetic aspect. I'm not literally... I'm trying to stay away from visualization. I really don't want to and I'm not really using sensors in the literal way or mapping any kind of data or information. And at the Maker Faire, I was describing myself as a sensor. And you could think of artists as sensors who are kind of attuned to certain things, and certain things make the cut, certain things don't. But it's part of the editing process. But this has been very much of a kind of intuitive thing where I'm kind of working my way through it and making decisions and yeah.
Okay. All right, let's give him a big hand. Thank you. It's fantastic. Amazing. Thank you. Okay. So I have a few housekeeping things, and check me if I'm wrong on this. So if you go to thebaylights.org, you can be part of the Gift of Light campaign. You can actually buy a little star or a pixel, I guess, right? You can buy a pixel. There are, as Jason says, there's a table right over there, and the staff is out there, right? Okay, and just two more things. Thank you so much for coming to Design Night. Please take the time to explore the gallery. The bars are still open. Make sure you can do light paintings, get your photo taken in a photo booth, and participate in I Just Want to Hold Your Hand, which is as intriguing as it sounds. And then the next Design Night is April 4. It's about robotics. Anybody like robotics? All right. That's an easy question, right? Make sure to sign up soon. Tickets will sell out. Autodesk.com/robotics. More information is available at the front registration. Thank you. See you next month. Thank you. Thanks again.